Thanks for coming to this session. So today we're going to talk about Micro Frontend. Quickly to introduce myself. If it does want to change the slide, would be nice. Yeah, perfect. My name is Audrey. I'm a full stack developer. I used to work for Saagie. I'm not working for the company anymore. So if you have questions on the product itself, I won't be able to answer. But if you had technical questions about Micro Frontend, I'd be delighted to answer. So to start, we're going to look through the evolution of our applications architecture. And to do so, I thought it might be easier to take an example that we all know about, the Java Petstore. I bet you missed this one, right? Yeah. So when it was launched by Sun, something around 2005, any languages it would have been written at this time, the Petstore would have been a classic end-to-end monolith. And then, front-end development became a thing, and all of this fancy JavaScript framework that we all love so much appear. And that's usually the moment when we began to split our monolith application into a front-end application and a back-end application. And then, microservices entered the game. So that's the moment where usually our back-end application has completely disappeared, being replaced by a set of microservices, each one being in charge of a specific part of the product. So, for example, for the Petstore, we can imagine having a product service and a search service and a checkout service. An interesting thing to notice there is the way our organization, team organization, is strongly tied to our architecture application. So, for example, when the Petstore was a monolith, we usually were just one team. We were the pet shop team. And when we started to separate front-end and back-end development, it's all the time when we usually separated our teams into front-end teams and back-end teams, with one being the customer of the other one, but not necessarily working strongly together. Don't know if you've been through there, but that has happened to me. I was working in the back-end team. I was having two front-end teams in front of me, one which was in the offices next door, and the other was in another city. And curiously, the one in the other city was having a little bit less information than the one next door. So that's the moment where some frictions might appear. And with Micro Frontend, usually what we are doing is that we are going to split the backend team and have several smaller teams, each one being in charge of one part of the domain, sometimes several, it really depends if the domains are small enough. So here, for example, we would end up with a product team and a search team and a checkout team. That's the first benefit of microservices, because having small and specialized teams means that they're going to do just one thing, but they're going to do it well. And usually, they will deliver faster than the biggest team. The second benefit is that microservices is giving us a lot of freedom in our stack choices. So if, for example, the product team wants to go with Java and the service team wants to go with Kotlin, it's not a problem at all. It will work anyway. So that lets the opportunity for each team to go on with the stacks which is probably the more relevant to them, but perhaps also the most comfortable to them. They're also easier to deploy, because when you get a new feature to deliver, you don't have to redeploy the entire monolith, the entire stack. You're just going to redeliver the product, the service, which has been upgraded, and that's all. You're done. And for the same reason, they're easier to scale, because you usually know which service will be more requested than the others. So you're just caring about scaling this one, let the other live their own way, and everything will be working fine. So if we're looking back at our front-end microservices and microservices architecture, it looks like everything is finally settled, everything is finally at its place, completely optimized, everything's perfect, and in fact, absolutely not. Not because, so first, you will end up with this architecture having a front-end monolith, which is just as hard to maintain and evolve than your backend monolith was. That's the first point. The second is that So you're still having, this kind of strange customer relationship between front-end team and back-end team, except that this time it's between front-end team and back-end teams. There are several teams for each part of the service, each part of the domain. And those micro teams, they will be delivering faster. But the front-end one, they are still the same team. They are still just one team in front of all of these micro teams. So it will probably just make the frictions even worse. And that's the moment when we have to move to the next step of architecture evolution, which is Micro Frontend. The core idea behind Micro Frontend is to consider the application as an aggregation of features. And so we are going to keep our small teams on the back-end side. But we are going to split the front end, both the product and the application and the team. And we are going to take each part of this front end and put them back in the back-end team, which is corresponding, meaning that so we will end up having still small teams, only small teams, but those teams will be in charge of their own part of the domain, their very specific part of the domain, from end to end. That's a classic way of working for e-commerce companies. Facebook is also doing it. Spotify is kind of doing it, but in a very strange way, so I won't talk about it. Some of those companies are sharing the way they are doing it, and I strongly encourage you to have a look at it because it's always very interesting. Not most of them, sadly. So, if we are looking back at our pet shop example, but slightly rebranded, it means that, for example, you will have this product team, which is in charge of this page. That's the only team in charge of this page. And the product team is going to use components provided by other teams. So, for example, here it will use the search bar provided by the search team and the checkout menu provided by the checkout team. And another big idea behind microservices is that we should keep the freedom we're having in our stack choices, the one that is bring with microservices, into the front end. Which means that you can perfectly imagine having the product team working in Angular, the search team working in Vue, and the checkout team working in React. So now we have only small and completely specialized team, and that makes a big difference. They are customer focused, which means that they don't have to worry about what's happening elsewhere in the application. They simply can think about providing the best experience to the user for their very own part of the product. For the product team, for example, it will be to present the product in a very clear way with probably related product, accessorize, etc. For the search team, it will be to have a very powerful and efficient search experience with a lot of filters or that kind of stuff. And for the checkout team, it will be to have a very smooth and fast payment experience so that you don't lose the client, So we're keeping the benefit of having small team, except that this time they are customer-focused team, which is even better. We are keeping the freedom in our stack choices, but now extended to front-end development, which is quite a big thing. Your team will be more autonomous in their development because if something is broken on the search part of the product, it has no impact on the product team and on the checkout team. They can simply continue their own way because their component is not related to theirs. Perfect. Plus, they will deliver more features more often. They are more autonomous in their release, obviously, because you don't have to wait for the front-end team to integrate these new features coming from the back-end. You don't have these frictions anymore. Your team are going to deliver them end-to-end, and that will be way much more efficient. And making your application evolving is made easier because you don't have, when you need to refactor the application, okay? It's not trendy enough or something is wrong. You don't have to do it in one move. You can simply planify it. You can do it component per component. say, okay, we're going to start with the search bar, and you can do it very, very slowly, more easily, without having the rest continue to work. So now that we've seen the theory, this bright, beautiful world where everything's going fine, let's move to a real-life study case, the data fabric. So data fabric is the name of Saagie's product, and it has all started with the manager. The manager is it's a kind of orchestrator for data scientists and data engineer, where they can upload, run, pipeline their data extraction and data processing jobs with all the tools they are used to have. It was released in July 2015, so kind of logically, but it was written in AngularJS. Then came the governance, which is the tool I've been mostly working on. This one is completely different because it's for business people, chief data officer, that kind of people who want to navigate through the data lake to be able to documentate the data inside. This one was released in March 2017, so you know AngularJS was already out of fashion. Let's move to Angular. And a few months later came operations. This one is completely different from the two others because the two others are completely tied to a platform, meaning they are coming upon a data lake, whereas operation is a kind of overall application to enhance the customer experience. It allows the user, so more probably a technical user, an operation guy, something like that, to monitor every platform. And at this point of Saagie's history, we realized a few things. We knew at this moment that we would have to refactor the manager. Because, okay, first of all, its workflow was not what the user workflow was. It was not working completely the way data engineer and data scientists were working, so we have to refactor this one. Then, obviously, the manager, when it was delivered, it was a monolith. It was, you know, the front-end, back-end architecture, so two monoliths. And so the security part was inside this monolith. Problem is, governance arrived, need to use security, operations arrived, need to use security too. Okay, so this part should probably be extracted somewhere, and probably with its own interface. Plus, we knew at this time that we were having the need for other tools like operations to enhance the customer experience. And finally, it was pretty clear it would have made no sense to have different applications for all of that. So all of those applications were needed to be presented together. And that's where the fun is beginning. So in October 2017, we started to work on the version 2 of Data Fabric. And we moved to a Micro Frontend architecture and evolution. So we were just two teams, one from the manager, one for governance. We splitted both teams into several smaller teams, each one being in charge of one application. On the human side, it went very smoothly. On the technical side, not that much. So it all started with Layout, which was released in December 2017, pure JavaScript. Then came Galaxy, our second try, in March 2018, this time in React. And finally, we ended up with Layout-as-Lib, which is also in JavaScript and which is in production since July last year. And this is what we are going to talk about, those experiments. So first of all, to give you an idea of what we were looking for, this is the version 2 of Data Fabric we were targeting. So you got a primary nav component on the left, which is letting the user move from a platform-related application to another one, governance and manager, for example. Then you got a top bar menu, which is there to let the user move from non-platform-related applications to other ones, security and operations, for example. Then you get a pretty classic user menu. And the main part of the page is the existing applications. So here it can be the manager or it can be governance, the Angular application. So before going further into technical details, I would like to say a word about design system. I don't know who amongst you knows about design system. Have you ever heard about? One person. Okay. So design system are a set of library, basically a library, a set of CSS styles and behaviors to ensure that you will have a consistent user experience. There is no point to go on for micro frontends if you're not going to provide a very consistent user experience. So the Saagie one is called Saagie-ui. It's you can't use it for commercial purposes, but you can definitely have a look at it, just to get inspired to make yours. So Layout, our first try, is an aggregation of web components as described on the microfrontends.org website. Don't worry about the links, I'll give you all of them at the end. So it's definitely the architecture we've seen with the Petstore previously, but this time each component is going to be a web component. So in our use case, the primary nav, the top bar, and the user menu are web components. But also, the main part of the page, which actually is the existing application encapsulated into a web component. So either the AngularJS application, the manager, or the Angular application. Quickly, to introduce web components, if you're not familiar with, it relies on 4 specifications, which can be used on their own, but used together allow the user to first define their own tags, thanks to the custom tag, custom element specification, whose style are completely encapsulated, isolated, thanks to a shadow DOM, so that you can completely mess your CSS part for your component. It will have no impact on the rest of the application, which is pretty good when you're as good as I am in CSS. With what we call with HTML templates, so basically it's fragment of markup which will be loaded at the first time and which can be instantiated on later on. And you get a consistent way of importing them thanks to ES modules. So how do we declare our own component? Pretty simple. You're going to create a JavaScript class, and this class is going to extend HTML element. Once you've done that, you have access to an API to manage the lifecycle of your component, and you're going to have 3 main methods that you are going to deal with. The first one, the connected callback, is called every time the element is attached to the DOM. The second one, the disconnected callback, is used every time the element is detached from the DOM. Pretty obvious. The third one, and probably the most important one, is the attribute change callback method. So this one is going to be called every time the value of an attribute of your component has been updated. Meaning that if your component has an attribute, let's say color, and it was instantiated with the red value, and the value has been changed by the user to blue, that method will be called. And then something that is not in the specification, but that you will see quite often, usually we declare a render method, because what we are supposed to do is to declare our markup, our component markup in the constructor, but then each time we need to update one of its tag, because the color element has been changed, so we get to change the color of the label. We're going to redeclare our markup in the attribute change callback. So we would like to avoid code duplication, and that's the reason why usually we declare the HTML in a render method. Once you've done all of that, the only thing you still need to do is to declare your component to the custom element registry. So you're going to call the define method and pass it 2 arguments. The first one is the tag that you would like to use to call this component. And the second one is the name of your class. And then using it in an HTML page is very, very straightforward. You're going to import it, obviously, so that your page knows about the existence of your component. Then to declare it like you would do for any other HTML tag. And, well, I guess you probably need to support some old version of browsers like Internet Explorer or whatever. So you might need what's called a polyfill. It looks like this one is the most stable and reliable at the moment. But the good news is, talking about support, that since last year, Firefox is supporting every 4 specifications. So only Edge is not supporting all of them. But as Edge has announced that they will just stop using their own engine and move to the Chrome engine, that will probably solve it at the same way. So how do you transform an existing application into a web component? So here it's the main page, the main JavaScript page of the manager application, the AngularJS one. And we are simply going to declare our web component, as we've seen previously. So it's going to be the data manager component. And in the inner HTML, we're going to declare a div. And this div is going to have as attribute the ng-app and the ng-controller of our application. In this case, as we need to pass information to one of its subdirectives, we're just going to declare it too, and that's pretty much all of it. You know, we simply declare our element to the custom registry, and we're done. With the Angular application, the data governance one, it's even much more simpler because you can simply take the top component, the top component from your application. So in our case, it's the data governance one, and directly declaring it into the inner HTML of your component. So very straightforward. Now, if we are looking at the way Saagie-Layout is done, so Saagie-Layout, the overall application, the one which will be in charge of displaying menus and charging the good components in function of the application requested. So first of all, it's going to import those 2 components we created. And then it's going to import the design system, so the Saagie-ui library. And then we're going to declare the SLA board component, which is our top-level component. This board component is the one who knows about every element it has to display. So it's going to declare the primary nav, the top bar, the user menu, etc. And to display the application, the selected application, it's going to call the getPage method. This method is going to look at the path the user requested, and in function of the path, is going to send back either the data manager component, either the data governance component. There were several benefits to this approach. First of all, it really gives us a very consistent user experience. No matter what was the application you were currently on, the overall menu will always look exactly the same because it was displayed by Layout, the overall application. Plus, we would have the possibility, if we wanted to display several components on the same page. We would have been able to display manager and governance side by side, for example. It was completely independent from the deployment point of view. Saagie-Layout was having its own life cycle, completely separated from governance and manager one. Perfect. But we didn't include other applications in this try because we quickly ran into several issues that were really blocking for us. So first of all, it's not a true single-page application at all. Meaning that every time you are moving from governance to manager or otherwise, you will reload the entire page. Plus, it has terrible performances. And the reason why is because we were not simply binding and unbinding components. We were binding and unbinding the entire application bundled into components, which is slightly different. Because the problem is those applications, they were coming with their own version of Babel, their own version of the design system, their own routers, and all that kind of stuff. So first of all, it was a very good way to have severe conflicts. And so we were having this kind of dependencies between libraries because to avoid those conflicts, we were needing to be sure that for example, every version of the Saagie-ui between governance, manager, and layout were the same. And the other problem behind is that so that's the reason why the performances were really bad, because they were not unbounded properly, those libraries. So the fact is, it could have been a proper single-page application, but it would have took us a massive amount of time and energy to properly unbound and then rebound all of those libraries. And we didn't put the energy and the time into it because we were having other issues that were so blocking for us that it would be worthless. It would have been worthless, sorry. Another big issue was the router management. Those two applications, governance and the manager, were coming with their own router based on hash, as it's usually the case nowadays. And to stay in a consistent state, the layout application has to know about every possible path of both sub-applications. So we were introducing a very strong coupling between those applications that we were really, really not looking forward to. And the last point, I would say last but not least, to be fully tested, it implies to be able to run the entire stack on your own laptop, which is at first not something you really wanted to do, neither something you could actually do. For example, on the security side, the stack is using FreeIPA. FreeIPA is not running on OS X. I couldn't test the entire stack on my laptop. So considering all of these issues, we decided to make a second try for the next application. So we decided to keep it, at the moment for the existing applications and to do something else for new applications to come. So we moved to the second try, Galaxy, which is, on an architectural point of view, exactly the same logic as the first try. But this time, it's going to be based on React fragments. Here, you're not seeing the primary nav component on the left because simply you're in an overall applications. So it's here, but it's hidden, but still present. So we're keeping the logic of our components, except that this time they will all be React fragments. And the idea was, in a second time, to use Tailor to stream them and have better performances, basically. I will not spend a lot of time on this approach, as it's very, very similar. The pros we identified before developing this second version, the Galaxy one, was that it would have gave us the possibility to share entire components and not only styles through applications. As the entire stack was supposed to be in React, the design system was moving from a set of CSS styles to a set of React components already styled and with proper behavior, etc. So that was pretty interesting. Plus, it would have gave us the possibility to have a centralized routing system. The idea was that Galaxy would know only about its children, only about the first part of the path, and that every children will then manage with the rest of the path. So long story short, as you may have guessed, it didn't happen as expected. It didn't went very, very well. We were still having the issue with library dependencies. We were still needing all of our libraries to be in the same version so that it works without having conflicts, etc. So that was really bothering to us. But we were having another issue of the same kind, but even worse. We're having the same with React version. The problem is, if security wanted to use a React component, which was not present in React versions of Galaxies, we needed to update the version of React of Galaxies, plus possibly the version of every other sub-applications, etc., in order to security to be able to use this component. So considering this, we stopped after the first try, the first integration, which was security, and decided to move to a third try. And for the third try, we completely reversed the logic and moved the layout from an application to a library. So we recycled, we are very ecologist, so we recycled our web component from the beginning, the primary nav, the top bar, and the user menu. except this time, instead of being in an application running on its own, there will be in a library, in a JavaScript, as lightweight as possible library. And this library will be then installed by existing application through NPM like any other libraries. So on the application side, here we are in the main HTML page of governance. It does not change a lot. The only thing we're going to do, so here it's the main HTML page, and we got our top-level component, the one we previously encapsulated into a web component. This time we're going to encapsulate it in a Saagie-Layout component, which is going to be hidden by default. Then, in the main TypeScript page of the application, we're going to look at the path to define if we are in legacy mode or not. If we are in legacy mode, we are not going to display Layout-as-Lib, fine, everything is just going its own way. If we are not, and we wanted to display the overall menu of the Saagie-Layout library, we're going to do two things. We're going to retrieve our component, our Saagie-Layout component, the one we encapsulated the top component with, and to ask it to show itself, and we're going to call the init method of the load layout data class, passing it several parameters. The first one is being the name of the application, so governance in our case. And that's all we need to do on the application side, on the existing application side. On the library side, so pretty simple. Try to keep it very, very lightweight to be efficient. The main JavaScript page is going to import its subcomponents. So those we've seen from the beginning, the primary nav, etc. Then it's going to import this load layout data class, which is called in the governance TypeScript file, and export it so that it can be used by other applications. The load layout data class is the one which is going to be in charge of making every API calls needed to properly configure and display those menus. Because those menus are completely dependent on the user rights and profile, etc. How many platforms can you access? Which one? Do you have access to governance? Do you have access to security, etc., etc.? So this class is going to do those API calls and only that. It's not going to do any change on the view, any changes on the view. It's only going to make API calls. So we started by retrieving the component, the Saagie-Layout component we encapsulated our top component in governance with, and thanks to the DOM API. And then we're going to call the load data method. And the load data method is simply going to make every API calls needed to have a complete profile of the user. If we're looking at the load write method, for example, it's going to send then to update some information about the user and some information about the set of platforms is allowed to see. So it's going to call the set platforms method, and the set platform method is going to call the attribute change callback method, because it's going to call the set attribute method with the proper parameters and the new values for these parameters being here the list of available platforms. And that's the only thing the load layout data JavaScript is doing. And then you get the layout, which is the top component we've seen previously. So it's a classic web component, connected callback method, okay, etc. And the attribute change callback method, which is the one being called by the set platforms method, is going to look at which attribute has been updated, and in function of this attribute is going to update components that needed to be. Because, for example, if the application, if the user was on the governance application and wanted to go on the manager application, on the resources, so you get to remove the highlight from governance and then put the highlight on the top bar on resources. So that's the job of layout, updating each subcomponent in function of what has been changed. You may have noticed that the render method is there called initRender, even if it's looking very, very similar to the render method we were having in our first try. The reason is that instead of having this getPage method we were calling to know which component to display, this time we're having this inner HTML. And this inner HTML, when the component is loading at first, is the existing application. For example, in our use case, it's the data governance top component. So you clearly don't want to reload it, by mistake. That's the reason why we thought it would be better to call it initRender and not render to avoid confusion. For the same reason, before declaring the component to the custom element registry, we are going to verify if it has not already been declared. So this solution is absolutely not a single-page application at all. Plus, we lost the ability to aggregate components. And actually, that's not a problem. The real problem was that we were not in the good use cases for the first two tries I show you, for the first two architectural schemas. So that's the moment when we are going to talk about page transitions. There is two types of page transitions. You get soft navigation, which is what's happening when you're moving from a page owned by a team related to an application to a page owned by the same team related to the same application. And in this case, the framework will more likely unbind and then rebind everything that's needed for you completely transparently. So the user will not even notice that it's not the same page. That's what's happening when I'm moving between domains and datasets in governance, for example. Hard navigation, at the opposite, is what's happening when you're moving from a page owned by a team related to an application to a page owned by another team, so related to another application. And in this case, it's pretty hard to avoid reloading the entire page. So, for example, that's what's happening when you're moving from manager to governance. You will pass from the AngularJS application to the Angular application, and in this case, you can't really avoid to reload it. So that actually is Saagie's main use case. It's not, Saagie's use case is not about aggregating components on the same page. There is no point on the business point of view to display governance and manager side by side. There are very big applications on their own that would be completely useless. They are not targeting the same kind of audience of users. More likely, Saagie is aggregating single-page applications. So they were more likely having hard navigation than soft navigation. And that's the reason why this solution, the third one, despite the fact that it's not a single-page application at all and that we can't aggregate components anymore, was the good one. Because obviously, displaying a lightweight JavaScript library is much more efficient in terms of performances than displaying an application encapsulated into a component displayed by another application. And it was a little easier to integrate. I think everything included, which means code review, NRT test, etc., etc. It took me 1 day and a half to deliver it in production. That's pretty nice. But the bad point of that approach is that it may result in a slightly inconsistent user experience. Meaning that, for example, the Layout-as-Lib team has delivered a new version of the library with a new menu item on the primary navbar. There's a new application in town, great, fantastic. Manager will immediately update its own version of the library for this new version and will display the new menu item. Whereas, well, on governance, I'm working on something else. I don't have the time for it, so it will have to wait. It means that during a short amount of time, the users might, when he will navigate from, for example, manager to governance, lose an item in the menu. So a slight inconsistency. We decided that it was not a problem because, okay, it's a risk, definitely, but on the other side, it gave us a completely independency, both on the deployment side and on the development side. Because if this new item was coming with a bug, that's things that happened, it was having no impact on governance. I mean, I haven't updated, so I don't have any impact. Everything is working perfectly on my side. I just have to wait for the next patch version of the library to be released. And on the manager side, for example, as they get already the latest version of the library, they can simply roll back to the previous one and not being impacted neither. That's pretty nice. Still, it's true that in case of breaking changes, you are more likely to be obliged to update each application at the same time. But here we are talking about simple NPM update, so pretty easy to do. It has happened, and it was fixed by the end of the day, I think. So. And the very interesting thing for us with this solution is that we were having no more libraries conflict, because before updating my version of the Layout-as-Lib, I would simply look at which version of the design system are you using. Okay, I'm going to update mine, and then I'm going to update my version of the library, and I'm done. And I won't have any conflict. Plus, and I'm pretty sure you understood that it was a big problem, so it's a big plus, this solution can be completely run on its own. You don't have to have the entire stack on your laptop to test it. What we were doing is that simply we were having some mocked Express server, so some very simple Express server which was mocking API calls, answers. If you remember the load data class, the one which was making all those API calls needed to configure the menu, you just have to mock the answers from those calls and you're done. You can completely test the entire bundle of both the application and the library on top of that. So at the end, the micro teams organization works really well for us. In 1 year, we've been able to deliver 4 new applications. We've been able to extract security from the manager, and we've been able to start refactoring it in a new application called Project and Jobs, while still having the manager in production. Some best practices, if you want to give it a try. So think about your use case first. I think, I hope this one was pretty clear for you. Are you going to do an aggregation of components, or are you going to do an aggregation of single-page applications? In other terms, are you going to have more light transitions or hard transitions? Take care of your design. So think about a design system first, but you can also think about little other things like optimistic UI, skeletons, etc. Optimistic UI is not an architecture. It is more likely a way of seeing things. So we're taking the approach that 99% of the API calls will have a positive answer. And we're going to display as quickly as possible a positive feedback to the user, which is especially useful when you're in an autosave application. You really need to say to the user that his action has been taken in consideration, the action has been done, here is the result. So we're taking the approach to say, okay, most of the time it will just go perfectly fine, and if it's not the case, we simply will roll back and display the error message. Skeletons is also something you should have a look at. It's very interesting. It's not a framework either, it's not an architecture or whatever. And you probably already know about it because it's used in Slack, Twitter, Spotify, LinkedIn, Gmail, about every application you're using in your daily life. Skeletons are those little shapes you're seeing when the application is loading, but there is no data at the moment. So it's a very good way to say to the user that, okay, I don't have the data at the moment, but I'm working on it. Something will happen in a very few time, so please wait. It's pretty cheap to implement, very nice feedback for the user. The only thing you have to care about, if you decided to go for, is to be sure that your skeletons will perfectly reflect your applications. So if you're changing something in the design of your application, don't forget to change it in your skeleton too. And last, but probably the most important, don't share resources, but don't share runtime. Even if you're going to use the same frameworks all over the stack, like for the second try, for example, don't share runtimes. You will just end up with a terrible mess. But do feel free to share resources, like, for example, I don't know, it could be pictures, it could be fonts, it could even be API calls for example, that's fine. If you want to go further, some links that might be useful. The microfrontends.org is the one I mentioned in the first try, the one we've been, the entire first try is based on. This site is maintained by Michael Gears, Natalitis on Twitter, who gave an excellent talk about microfrontend at WebRebels Oslo last year. The site on itself is already full of information, but there is also a GitHub related to, with two kind of examples, one with custom elements and one with server-side includes, which is something you would like to have a look at if you're going to make aggregations of components. Experiences using microfrontends at IKEA, that's an InfoQ article. So it's about, obviously, the way they've been doing microfrontends at IKEA. Not highly technical, because, it's kind of their own recipe, so they don't really explain the way they're doing it, but very, very interesting to read, to understand the way they've been thinking about the problem. Project Mosaic, it's a set of libraries to aggregate fragments. It has really been to aggregate fragments. Taylor is probably the most popular among them. It's open source by Zalando, very nice project. And Single SPA, it's another JavaScript library that has been created to aggregate small single-page applications together, so you might like to have a look at it too. That's all for me. Do you have any question? Yeah.
Quick one. Can you share the state between the different applications?
How do you keep the state coherent between applications? That's it. You mean in the third try?
Yeah. So let's say you have the library, you have it like all the different applications. Have a state that you want to share and have it available in other.
I'm sorry, the door is open. Sorry, I didn't have the last part.
I want to share the state from one application to the other one.
Yeah. So that's the very important point with the third application. How do you share the state between existing applications which are displayed? And I won't say it's not supposed to happen, because it has happened occasionally. That's the reason why I insist so much on the think about your use case first, because the approach we took is very related to our use case in the way that manager and governance were not supposed to share information. They're working on very different things. But at some point, one of the applications that has been developed after all of them has to share information. It's all about security, managing the data lake, etc. So it has to share it between all of those applications. And the way we were doing this is that we were having an event-driven architecture using Kafka. And so we were sending, everything was going through backend application, sent through the event bus with Kafka, and then displayed. Yeah?
What do you do about any information shared but used by the layout rather than the application, such as your sidebar? Is that just loaded again in the page, or is that somehow hacked around?
You're talking, for example, so what about the information which are shared between the library, the menus, and the main application.
More like when the layout renders its sidebar and it determines which application to render, do you determine that every time you go to the application, or do you remember that?
No. I try to remember how it was done, actually. No, if the element was already declared in the registry, we won't make the call again. So we're keeping the informations. We're just updating parts that are needed with new informations that might be available at this time, might be needed, etc. Another question? So I think that's all for me. Thank you very much.